Hi students. In this video we're going to go over basic creation techniques for Solidworks sheet metal parts. I've started a normal part as I always do, and I'm going to draw a sketch. There we go. I have a fully defined sketch. That's going to become my starting piece of metal. Now I'm going to say insert, sheet metal, and base flange. Base flange is going to be your starting feature. I strongly recommend that you come over here and click on Use Gauge Table. Sheet metal is always sold by gauge. It's never sold by a fraction of an inch. So you can't go into a dealer and order 1/16 of an inch sheet metal or a 32nd of an inch sheet metal. Let's go down to the various tables. I typically use the bottom one, which is simple sheet steel. And now we can choose the appropriate gauge thickness. I'm going to use 16 gauge. The gauge numbers are roughly 1 over the thickness. So for example, 16 gauge is roughly 1/16 of an inch thick. And you can see in thickness T1 right here, it comes in at 0.0598. So very close to 60 thousandths of an inch, which is pretty close. Down here we have our inner bend radius. This you can modify if you choose to. 0.075 is pretty good for 16 gauge sheet metal. Okay, K factor. K factor and the auto relief, I wouldn't mess with these. The reason is that when you do sheet metal, when you put a bend in, you do something called plastic deformation, which is you're bending the metal to the point that it takes a set. And your metals are stronger in compression than in tension. So the outside edges tend to stretch. So if you were to actually mathematically figure out all your center lines and do the dimensions for what you thought a flat pattern should be, it would come out wrong. You'll find that you have to take the stretch of the metal into consideration to get an exact object post-bending. But let's keep going. We'll just keep that in mind. I'm going to say OK, and I start off with a sheet of metal. The most typical thing you're going to do now is you're going to put some bends on it. So I'll go back to Insert, Sheet Metal. Now we have a whole bunch of different options. The most common one is edge flange. And we're just going to go around and we're going to click on all the edges that we would like. Whoops. I clicked on the box. One, two, three. And 4. So you can apply the flanges individually if you'd like to control their parameters individually, or you can click on all the edges at one time and control them as a group. As you can see, as I move my mouse, the flanges will either reverse direction or extend. If you would like to type in an exact flange length, you can do that right here. So I'm going to set it at 1 inch. And I'm going to say OK. And I get a box. Well, I don't really care for that. I think I'd rather reverse the flanges. So I'll edit the feature. Oops, wrong one. And I'll just flip my flanges around. There. That's nicer. But the box is a little too plain for my taste. Maybe I'll do a box that has 45-degree flanges. Okay. We can go back in. We don't necessarily have to have 90-degree bends. Let's say I want them all to be 45. I can change the angle to 45, and the box immediately opens up. Well, if I want to put something in my box, I have very large edge gaps, and I can fix that by closing the edges. So I'll say Insert, Sheetmetal, and I'll close the corners using Closed Corner. Click on a face. And let's zoom in and see what Solidworks is proposing. Well, that's kind of an ugly looking corner. There are different corner types. So I can either make them overlap, underlap, or butt. That looks a little cleaner. I could come in later and then have my welder weld the seams together in here. So I'll say OK to that. And now I've got a nice little tray with 45-degree sides. Okay. Well, that's pretty nice. So you're probably saying, well, I could have drawn that with just extruding and chamfering and maybe a little shelling. So why do I care about all this sheet metal stuff? Well, it's very simple. If I come down to the very last item, you'll see it says flat pattern. So I'm going to click on the flat pattern and say unsuppress. And now it takes my sheet metal part, lays it out flat, and now I can take and generate a file called a DXF, which is nothing more than a file with a bunch of curves in it. And I can send that to a laser cutter or a plasma cutting house, and they can make this part exactly from my Solidworks file. In fact, when I did the wind tunnel vanes in Crosby Hall, this is exactly what I did. I drew them as sheet metal, I flattened the part, I emailed the files to a laser cutting house, and they made every single turning vane without a single blueprint. So it can be a huge time saver. If you'd like to see your part rebent, simply suppress the flat pattern, and it bends back up. Now, on your edge flanges, let's expand this and take a little closer look. You'll see that there's a sketch for each individual flange. Now we can go in and we can modify these sketches if we choose to. So for example, if I'd like to put some fancy contouring in this flange, I can modify sketch 15, and I will edit the sketch. So maybe I want an elliptical cutout in it or something like that. And yes, I could certainly put that in as a cut feature after the fact. But if for whatever reason I want to modify my sketch, I can do it. So now when it rebuilds, I have an elliptical cut in my sketch. As I was alluding to, you still can do all of the usual pre-programmed features. So for example, let's say that I want to fillet this edge and cut it back. I can certainly do that. Go. Or if I want to chamfer an edge, I can still do it. Let's see, we'll come down here, we'll make this 1/2 inch. And even with those new features, it will still show up properly in the flat pattern. One of the questions that came up from last year's class before the exam was, if I'm looking at a question, how do I know the part is sheet metal and that I should draw it as sheet metal on the exam? And the answer is very simple. If you see a part that's all uniform thickness, chances are it's best drawn with sheet metal. So I will rebend that. And there we go. Okay, so that's drawing a native sheet metal part. But we can also convert other types of parts. We can start with a traditional solid model and convert it. Let's try that. I'll get rid of this. Let's draw a new part. I'm going to start a sketch as always. I'll smart dimension my sketch because I don't want to have to take points away from myself. Exit the sketch. And I'll extrude it. For direction 1, I'm going to make this 1 inch thick. And now I'm going to shell this box. So I'm going to say I want to pierce the top face, and I'm not even going to set the thickness correctly. Let's make it 0.08 inches. Well, there's no sheet metal out there that's 0.08. But we have a nice little hollowed out box. Now let's convert this to sheet metal so that we could actually create some kind of an enclosure or covering for a piece of machinery. I'm going to say Insert, Sheet Metal, and Convert to Sheet Metal. Again, I'm going to use the gauge table. Oops, accidentally clicked on aluminum. So we'll go steel and English units. We'll choose 16 gauge again, because that's a very common metal thickness. Okay, the first thing we have to do is right here. Select a fixed entity. What Solidworks is asking is, where do I unbend everything from? So I'm going to fix the floor of my box so that all these other edges flip downward and unfold. We can set our bend radius. That looks about right. Now we have to say where the bends are. So I'm going to click in the Bend Edges box. I'm going to go right around the inside of the box. Okay. These rip edges, this says, where should I slice the box to create the flanges that are going to fold down? In past editions, you would have to say, this is my ripped edge. But Solidworks has gotten smarter over the years. So we're going to go with that. The gap, let's see, we'll set this, we could stay with that. I'll set it at 0.03. And we'll say OK. Solidworks thinks a minute. And now, what was a simple extruded box is now a piece of sheet metal. And again, we can flat pattern it. And that is how you do a sheet metal conversion in Solidworks. Thank you for watching.